Hello, this video is on section 3.1, beginning on page 117. We are going to be talking about quadratic functions in vertex form. Now, here's the vertex form of a quadratic function. F of x equals a parentheses x minus h close parentheses squared plus k. Now, this is the vertex form, and it's actually very, very useful, because the vertex forms tells us the attributes of a quadratic function. If we can look at the vertex form, then we can easily find a, h, and k. And what can we do with a, h, and k? Well, the graph has the vertex hk, and the axis of symmetry is x equals h. And then, if a is greater than 0, then we can find that the f of x has a minimum value of k when h equals x. The domain of f of x is going to be x such that x is an element of the real numbers. This is basically saying all real numbers. And the range of f of x is y such that y is greater than or equal to k. And then f of x is decreasing on the interval negative infinity to h and increasing on the interval h to positive infinity. And when a is less than 0, f of x has a maximum value of k when x equals h. The domain of f of x is x such that x is an element of the real numbers. The range of f is y such that y is less than or equal to k. F is increasing on negative infinity to h and decreasing on h to positive infinity. So depending on whether a is greater than 0 or a is less than 0, you're going to use either this or you're going to use either this. One or the other. You cannot use both at the same time. So can you see, just by looking at the vertex form of a function a, h, and k, we can find a, h, and k. That tells us everything we need to know about the quadratic function. Alright, let's look at an example here. Alright, so we looked at this vertex form right here, and I asked my students, what is a here? Well, it's 4. H, notice here we have negative 3. And so when we're talking about the vertex form, whenever you're looking for h, you're always taking the opposite value. So if we have negative 3, what is the opposite of negative 3? Well, it's going to be positive 3. And it's only for h that you take the opposite. So, and then k is going to be the number itself, which is 5. Alright, so we found a equals 4, h equals 3, and k is equal to 5. 4, 3, and 5. That means that the vertex, which we found out to be hk, is simply going to be 3, 5. And the axis of symmetry is going to be x equals h, which is 3. Simple as that. Just by finding a, h, and k, looking at our function, we can find what the vertex and the axis of symmetry is going to be. By the way, just so you get an idea of how this looks like on the graph, the vertex is the lowest or the highest point of a parabola, and the axis of symmetry goes through the vertex. And basically, can you see how the axis of symmetry divides the parabola into 2 equal halves, or divides it down the middle, basically? Now, here's what we have to figure out. If we know that a is equal to 4 Is a going to be greater than 0 or a is going to be less than 0? Well, a is going to be greater than 0 because a is equal to 4, which means 4 is greater than 0. What that means is we're going to use this information right here, and we're not going to worry about for a less than 0. So that means that all we have to do, just by finding a, h, and k, we can just simply plug it in. Remember, we said that when f of x has a minimum value of k when x is equal to h. Well, we know that k is 5 and x is equal to 3. So f of x has a minimum value of 5 when x equals 3. And notice here the next attribute is the domain. The domain of f of x is all real numbers. And notice we don't plug anything for the domain. It's basically always going to be this answer. So the domain is all real numbers. The range of f of x is y such that y is greater than or equal to k. We found out that k was 5. And finally, the last attribute, f of x, is decreasing on negative infinity to h and increasing on h to positive infinity. So h is 3 here. And that's it. Can you see how just by finding a, h, and k, we can easily find all the attributes of our function just by looking at the vertex form? That is it. Let's look at one more example. This one is a little bit tricky. Notice a, all we see is a negative. Well, that's basically a negative 1. H, we're always taking the opposite. So if we have a negative 0.8, our h, the opposite of that, is going to be a positive 0.8. And what about k? K goes all the way at the last, but we don't see anything. So if you don't see anything there, it's going to be 0. So remember, the graph has the vertex hk. In this case, h is 0.8 or just 0.8 and k is 0. So there's my vertex. And it has the axis of symmetry x equals h, which is 0.8. Now here's the important question. Is a greater than 0 or less than 0? Well, a is negative 1. Negative 1 is less than 0. That means we're going to use the setup for this time. We're not going to use this right here. We're going to use when a is less than 0. So now here is the one we have to fill in h and k for. Alright. So f of x has a minimum value of k. Is that correct? Shouldn't be minimum. Should be maximum. So because a is less than 0, we should use a maximum value of 0 when x is equal to h, which is 0.8. Notice, again, the domain always stays the same. It's all real numbers. And the range of f of x is y, such that y is less than or equal to k, which is 0. And finally, f of x is increasing on negative infinity to h, which is 0.8, and decreasing on h, which is 0.8, to positive infinity. So notice that since we're using a is less than 0, we change minimum. We don't have a minimum, we have a maximum. And we are increasing from negative infinity to 0.8 and decreasing on 0.8 to positive infinity. Alright, so it's very important that you use the correct one of these. If you use the wrong one, you're going to have some errors. Notice how these are different here. And then the inequality here is different as well. So make sure you use the correct one, or else when you plug them in, you're going to get the wrong answers. Alright, so what I had you do is work page 127, 2, 3, 4, and 5. So again, the vertex form is very important because we can find the attributes very easily. Which brings us to the next question. What if my quadratic function was not in vertex form, such as a x minus h squared plus k? What if it wasn't like that? What if my quadratic function was in the form ax squared plus bx plus c? By looking at this, I can find what a is, but can I find what h and k are? No. So now here's the question. Is there a way to go from standard form into quadratic form, or standard form into vertex form? To go from here to here. Yes, there is. And to begin to learn how to do this, we actually have to start with something that seems almost irrelevant. But there is a way to connect these ideas together. So what I had my students do is go all the way back to elementary school and tell me what the area of this square was. So the area of this square is 100. How'd you get 100? Well, the students correctly told me you multiply 10 times 10. That gives you 100. Alright, too easy. And I had my students work this out. Well, what's the area of this then? Go ahead and find it out. So I gave them 2 minutes to find the areas. And so when I looked around, some of them were able to find the area of each individual rectangle or square, and they added them together and they found that the area of this square was 36, which is correct, 36. So 16 is basically 4 times 4, 8 is from 4 times 2, same thing here, and then 4 is from 2 times 2. And so this is what I had them write out. I had them write 16 plus 8, which is 16, plus the green square, which is 4, equals 36. But then I asked my students, what did we do here? We took the 10, which is the dimension of this side, times the 10, which is the dimension of that side, and multiply them together. So we get 10 squared, which is equal to 100. And I did get some students that were able to do this as another way to solve for the area. They basically took 4 plus 2 and just as we squared this 10, we square this 4 plus 2, which is 6, and we take 6 squared, and that also gives us 36. So 4 plus 2 squared is 36, which is equal to 16 plus 4, which gives you 36 as well. And so there were 2 different ways. We can add up the individual pieces and add them together, Or we can take the dimensions of the whole rectangle, or of the whole shape, which the whole square, and compute it that way. And so now we started getting into Algebra 1 stuff, and I asked them to calculate the area of this, giving me both sides of the equation. So you had to give me how to find the area calculating all the individual pieces, and how to find the area calculating the dimensions of the whole shape. And so what we did here is, to begin with the individual pieces, we multiplied x times x, which is x squared. 6 times x, well, the area here is 6x. 6 times x again, we get the area 6x. And then this green square is basically 6 times 6, which is 36. So if we write all the areas of all the shapes, all the different colored shapes, this is x squared. 6x plus 6x is 12x plus 36. So this is the area. But just as we did here, we can also take the dimensions, add them together, so we have x plus 6, and then going all the way back to what we did here, take the dimensions, multiply them together, which is basically squaring it. And so we take 6 plus x plus 6 squared. This right here is the same thing as this. Either way, you're going to get the same area. Alright. So now we need to go beyond Algebra 1 and start getting into Algebra 2 level. So here's what I give my students. Instead of giving you the dimensions, what if I gave you the area of this rectangle, this red square I mean, and then that's all I gave you. But then I told you if I take this blue area and this blue area and add them together, it's going to be equal to 6x. Find the area now. So this rectangle is this one right here, and this rectangle is that one right there. If both of them together equal 6x, how can I find the area of each individual one? Take a minute to find that out. And so I gave my students some time to figure that out. And then I walked around and some of them were finding it easily. Well, if both of them equal 6x, I basically take 6x divided by 2, which is 3x, which means that this is 3x and this is 3x. So how is that going to help me find the area of this green rectangle? Well, I have to write the dimensions out, which means that the dimension of this red square is x by x. The dimension of right here is going to be 3 and 3. And so now to find the area of the green rectangle, green square is basically 3 times 3, which is 9. There we go. It is 9. Which means that x squared plus 6x, which is 3x plus 3x, plus 9 is equal to x plus 3. That's taking the dimensions here and squaring it. There we go. So, can you see how in the beginning I gave you this information? I gave you that the area of this red square was x squared, which is right there. And then I gave you 6x, which is right here. So just having this information right here, I was able to find the rest. Plus 9 is equal to x plus 3 squared. So now we need to migrate from our diagram and just focus on looking at the equation. How can I just look at the first x squared and x and find the rest? How can I find the rest here? Just by having these two. That's the critical part here. Notice x squared is this rectangle, red square right here, and 10x is basically these two blue rectangles. So if I find the area of this green square, can you see how that completes the square? So all I have is this right here. How can I find the area of the green square so that I can complete it? Well, what did I do here? How did I get this 9? Just by looking at my equation, how did I get this 9? Well, 9, I got it from 3 times 3. Where'd you get 3 in the beginning? Well, 3 I got it from 3x, which came from 6x. So I take 6x, divided it by 2, which gave me 3x and 3x, and then I was able to get 3 times 3, which gives me 9. So just looking at x squared plus 6x, what can I do here? Well, I take 6 divided by 2, which gives me 3, and then I multiply 3 by itself, and then square it, which gives me 9. Can I do the same thing here? I take 10 divided by 2, which gives me 5, and after I have 5, I square it, which gives me 25. Is that the number that goes here? Well, let's confirm it. Here I have 10x. If I divide it by 2, then each rectangle is 5x. 5x goes here, 5x goes here. And if I write out the dimensions, it indeed is 25. Yes, it is correct. There we go. So if by adding 25, can you see how I completed the square? Now I have a complete square. So is this always going to work? Yes. And basically the formula is you take 10, you divide it by 2, and then you square it. Be the coefficient of the second term. The one with the x, you take that number divided by 2 and you square it, and then that completes the square. That's always going to be the case. Now we have to figure out, well, we completed the square here, we got 9, and then we have to find the other side of the equation, which is x plus 3 squared. How do we get x plus 3 squared? Well, basically notice that here we always have x squared, so the dimension is always going to be x. So we can go ahead and write that down. We can always have x here, and it's always going to be squared. But how do we find this number here? How do we get the 3? Well, that came from 6 divided by 2 equals 3. So what we need to do here is basically take just the inside of the parentheses, and that gives you what number goes here. And so 10 divided by 2, which that's 5. And there we can, what we can do is we can just focus on the equation and complete the square using this, and then we can set it equal to and fill out the other side of the equation using just inside the parentheses, where we're always going to have x parentheses and squared. We just have to figure out what number this is, and we get it from inside the parentheses here. So there we go. we have the fundamental idea of what we need in order to begin some exercises. So we're no longer looking at just diagrams. What we need to do here is start looking at just the equations. Now, how is this one different? Well, notice here we had just x squared. Again, here we have x squared. But here, notice that we have a coefficient not of just 1, like we had here. This is an invisible 1 right there, this is an invisible 1 right there, a 1 right there. This time we have 4. So we can complete the square if our coefficient is 1. So what we need to do here is we need to divide the first two terms by 4 in order to get a coefficient of 1. So we're going to divide this by 4, and we have to divide this by 4. What that means is that I'm going to write 4 on the outside of the parentheses, and whatever I'm left over, I'm going to write inside the parentheses. So 4x squared divided by 4 is going to be x squared, which is what I want. I want to get x squared. And then I'm going to write the rest. 16x divided by 4. Well, that's 4x. There we go. Now, if you look inside the parentheses, that's what I've been working with in the past, all the past examples. So now that I have x squared plus whatever the second thing is here, I have 4x. I can go ahead and complete the square, and then I can write the rest of the equation. So, how do I complete the square focusing inside the parentheses? Well, the first thing I need to do is I need to take the number in the middle, my coefficient of x, which is 4. I'm going to divide it by 2. Remember, here we took 10, we divided by 2, and then after we divided by 2, we squared it. And so 4 divided by 2 is 2. 2 squared is equal to 4. And that is going to complete my square. Now, plus 4. Now, notice, here I could add 25, and then I could write the rest of my equation. But because I took out a 4 here, I divided by 4, I put the 4 outside the parentheses, and then I added 4 inside of the parentheses. Because I added 4 inside of the parentheses, what that means is that I have to subtract 4, do the opposite outside of the parentheses. I added 4 here, so that means I have to subtract 4 outside of the parentheses. And because I divided the first two terms by 4, that means I have to multiply this minus 4 by 4 in order to keep everything balanced. And so now I have everything balanced here. I have, since I added 4 inside the parentheses, I have to subtract 4, and because I multiplied by 4 here, I have to multiply by 4 here. And so now I can continue doing the rest. Remember when we took this, x squared plus 4x plus 4, I have to find what it's equal to. And remember, it's always going to be x and it's squared. I just have to figure out what goes here. And the way I figure that out is basically just looking inside the parentheses here. What is 4 divided by 2? Well, that's positive 2. And so that completes the whole rest of my equation. Just what I did here. And so what I'm going to do is instead of having this right here, I'm going to replace it with this. So here's what I have. I have 4x plus 2 squared minus 4 times 4, which is 16. And now, take a look at this. What do I have here? Here is the vertex form. So going all the way back, let's see here. I started with the standard form. By the way, this is 4x squared plus 16x plus 0. I didn't have a constant, but this is still the standard form. And I went from standard form into vertex form, which is this right here. And so can you see, just by looking at the vertex form, I can find A, H, and K. Here, A is going to be the number in front, H is going to be always the opposite sign, and then K is right at the end. So A here is 4, H is always the opposite, so plus 2, the opposite of plus 2 is negative 2, and then K is negative 16. And so we took the standard form of an equation and we completed the square, and once we completed the square, we put it into this form right here, and that is able to get us the vertex form. And from the vertex form, we can find H and K, which means once we have H and K, we can go ahead and find all the different attributes of a quadratic function. Going back to this. So we started with a very simple idea of finding the area, and by working through that, we learned the concept of completing the square, and then we're able to set it equal to this other side, and that helps us find the vertex form of a quadratic equation. And so let's take a look at one last example. Again, we're not looking at the diagrams anymore. We want to look at just the functions. So here's standard form right here. Ax squared plus bx plus c. So let's go through the steps of finding the vertex form. First thing that we want to do is we want to just get x squared. So I have to divide the first two terms by 2. So 2 goes on my outside. X squared, 2x squared divided by 2 is going to be just x squared. 12x divided by 2, well, that's going to be 6x. And then, since I only divide the first two terms by 2, that goes, whatever result I get goes inside the parentheses. This 10x, I'm just going to put it outside parentheses, which goes on the outside. And so now, the reason we divided by 2 is so that we can concentrate on this now. Now we have x squared plus 6x, and we can go ahead and complete the square. So how do we complete the square again? We take the middle number, the coefficient of x, divided by 2, and we square it. Same thing that we did here, same thing that we did here. It's always the coefficient of x. And so what is 6 divided by 2? Well, that's 3. We square it. 3 squared is 9. So we have to add 9 here. And again, because we added 9 on the inside of the parentheses, we have to subtract 9 on the outside. And because we divided by 2, we basically put this 2, we divided by 2, we have to do the opposite, which is to multiply by 2. Alright, everything seems balanced now. Now, what I want to do, this is plus 9. What I want to do now is I want to write the other side of the equation of this. What do I mean? Well, x squared plus 6x plus 9. What is that equal to? Remember, we want to set it equal to this, something like this, something like this. And notice, we always have x, our dimension is always going to be x, close parentheses, and we're always going to square it. So how do I find the number that goes here? Well, that's going to be the result of the inside of this parentheses. What is 6 divided by 2? Well, that's positive 3, so plus 3. And then I got a question from my students, and they said, what happened to this 9 then? What do we do with that? Well, here we had 9, and then can you see how we took the dimensions, x plus 3, x plus 3, x plus 3, x plus 3. This 9 came from that 3 times 3, which gave us 9. So we don't need the 9 to get the other side of the equation. Or we don't need to write the 9 on the other side of the equation. So x plus 3 squared. What happened to this 9? Well, that was part of the area that we got from the dimensions. Alright. So what I need to do now is I need to replace this with this right here. So 2 x plus 3 squared. And now I can simplify this. What is 9 times 2? Well, that's going to be 10 minus 18. What is 10 minus 18? Well, that's going to be minus 8. There we go. And let's call this function f of x, f of x, f of x. And now, finally, we have the vertex form. Where we have ax minus h squared plus k. So can you see how we went from standard form, this, into vertex form, which is this right here. Now we can find a, h, and k. A is 2, which we can find looking at standard form, but now we can find h, which is the opposite. H, what is the opposite of 3? That's negative 3. And k is going to be negative 8. There we go. Now that we have a, h, and k, we can use this right here to find all the different attributes. And also we can find the vertex and the axis of symmetry. So there we go. That is how you complete the square in order to go from standard form into vertex form. Thank you for watching.